Away. So for this video, we are talking about quadrilaterals, right? But something that is very important before I forget is to talk about just a little bit about angles, right? So I have two lines. Both of these lines, they are parallel to each other, right? And then I happen to get a straight line like this, and it doesn't matter even if the straight line is like this, right? Let me use this one, right? Here you have a couple of, right, so this is vertically opposite angles, right? So all the angles in blue, they are vertical opposite angles. You see this angle, vertically opposite angle. This one, it's not even about parallel lines. If you have two straight lines, they give you a pair of, if you have two straight lines bisecting each other, they both give you a pair of parallel of vertically opposite angles. Angles that are opposite to each other, right? They are always equal, and the reason for that is vertically opposite angles. So now I'm gonna use red for corresponding angles. So we would usually say chorus angles, right? Corresponding angles, they form an F, right? You see an F, these angles, right? Yeah, so in that case, we are talking about this angle, right? It has to be equals to this angle, right? This is corresponding angles. Another pair is gonna be this angle. It will be equal to this angle. Let me do something like I'm coloring it. But yeah, this angle, it will be equal to this angle, right? So just remember that. And this is because of the parallel lines. It only happens if you have two parallel lines, and then you have a line bisecting both of these parallel lines. Corresponding angles are formed, and it could be either this and this pair, or the one that I shaded. Cool. So we talk about another pair, which corresponding vertically opposite, alternating old angles. Alternating angles, they form a Z. Yeah, they form a Z. So we look at our diagram. Let me remove this. We've already spoken about them. What am I doing, man? So yeah, they form even like a Z in a way, right? So this angle right here and this one right here, they will be equal, and the reason for that will be alternating angles, right? And again, this angle right here, it will be equal to this angle right here. Now, alternating angles, very important to understand. We go further, right? So I think in terms of identifying these angles, we are done. One last thing before I close off this section, it's co-interior angles. So you see, let me call this angle X, and let me call this angle Y. So you see, if we have a parallel lines, and then that parallel lines is cut by a straight line, then it forms these two angles within the what is this, within the inside, man. I don't, English is just running away right now for some reason. But what then you would do, you would say X plus Y, angle X plus angle Y equals to 180 degrees, and the reason is interior angles, right? Co-interior angles, right? Yeah, so these are the main things that I wanted to converse with you guys about the angles, and yeah, after this we're gonna jump straight. Even right now, let's jump straight to talking about quadrilaterals. So in short, we spoke about triangles, and these are shapes with 3 sides and 3 angles, ne? Triangles. So now when we're talking about quadrilateral, we are talking about a shape, right? A 2-dimensional shape with 4 angles, 4 sides. You see, we have 4 angles, we have 4 sides. That is quadrilateral. It's not a quadrilateral if it has less than or even more than 4 angles and 4 sides, ne? Yeah, so basically here I'm gonna do this thing that students don't like, ne? I'll be basically reading, you know, when a teacher comes and instead of teaching they start reading the textbook and reading exactly what is there, you know. It's not fun, but yeah, the thing is here I really have no idea if there is anything that I may need to explain than actually emphasizing that know these properties. Ne? So we have a couple of quadrilaterals we'll go over, but the most important thing about all these quadrilaterals is that you have to know the properties of each and every quadrilateral, right? When you have a shape there and you see certain properties, let it remind you of a particular quadrilateral. You get me, right? And the thing is, now once you master this from here, I'm telling you, grade 10, 11 and 12 is gonna just be up and work. And people always cry about Euclidean geometry. I'm just here to make it easier for you, né? Yeah, so we will do so many examples together to make it way easier. Yeah, so first and first we have a parallelogram, right? For a parallelogram they will just tell you, hey, for a parallelogram, right, these are the properties of a parallelogram. So you see a pair of opposite angles are equal. Look at angle B and look at D, right? A pair of opposite angles are equal. Look at C and A. These are opposite angles and yet they are equal, right? Let me see if we have, yeah, both pairs of opposite angles are equal, right? And also look at this, we have diagonals, diagonal AC, diagonal DB, right? They bisect each other, and this is very important, né? This line from here to the center equals the line from here to the center. What am I saying, bro? What am I saying? Okay, cool. Let me put a letter here and say K, right? So AK equals to CK, right? AK and CK, same length, right? DK and BK, same length, right? So you see it by these, right? So that means that this is the midpoint, right? This is the midpoint of each of every diagonal, right? It's the center of all the diagonals. It's the center for both diagonal BD and AC. Did they mention it? They didn't, but oh yeah, they just said both diagonals that bisect each other, right? And of course a pair of opposite sides, they are equal. So you see here they're equal, and also they are also parallel. A pair of opposite sides are parallel. So whenever you're being asked to say, hey, I'm gonna prove that there's a parallelogram, just remember the properties of a parallelograms and try to take them out from the diagram, and then you will say, because of these properties that I see, this shape, it has to be a parallelogram, right? So now I like to say that a parallelogram, it is a pushed triangle, it is a pushed rectangle. That's what I like to say, because both of a pair of opposite sides, they are both equal and parallel. That is the same thing for a rectangle. And then our diagonals, they bisect each other, right? And since our diagonals bisect each other, also if I do another k here, right? We have the same thing where AK equals to CK and BK equals to KB, right? So that's the thing. So what now makes a rectangle different from parallelogram is that for rectangle, all diagonals are the same length, right? Let me see if they have it. Diagonals bisect each other. Okay, diagonals are equal in length. So diagonals are equal in length. When you see that, a rectangle, right? And then also another thing, you can say for rectangle that a pair of opposite angles are equal, because opposite angles, the pair 90 degrees, right? But you can also say that all interior angles are equal to 90 degrees. Something to remember, that for all the quadrilaterals, all of them, the angles add up to 360. Right, so all these for 90 degrees, they give you 360 degrees. Then you wonder, do I go to sleep? Yeah, I just hope that this yani doesn't make you guys want to go to sleep. But yeah, these are the properties. A pair of opposite sides, also they are parallel, so the side is parallel to the side, and this side too is parallel to the side, and the opposite sides are equal, right? Both diagonals, right? You see that you form an isosceles triangle here and making this angle be equals to this one, right? You have another isosceles making this angle equals to this one. So yeah, man, this is a rectangle. We go again. Beautiful stuff. We talk about, I believe this from here, that is square, right? So now we talk about the rhombus and a square, right? Let's talk about what's the same about them. All sides are equal. That's the only thing that's the same, right? All sides are equal, right? From all sides being equal, what do we have? We have what do we have? Okay, we have, of course, a pair. Also, what's the same is a pair of opposite sides are parallel to each other. So this pair is parallel to each other, this pair is parallel to each other, right? And remember, whenever we're talking about parallel angles, we can end up having your co-interior are always there in most cases, so long as there's an enclosed shape, there will be co-interior angles. So yeah, and then a square or angles 90 degrees. Here a pair of opposite angles are equal, right? And then the rhombus, the diagonals, they bisect at each other, forming a 90-degree angle, right? I think that also could be the case for parallelogram, but apparently not. But yeah, diagonals bisect each other 90 degrees. Yeah. Oh, I'm thinking of kite here. But yeah, diagonals, they bisect each other 90 degrees, and of course here your diagonals are not equal in length. They are not equal in length, but yeah. Away. So another quadrilateral we can look into is called trapezium. Okay, so far all the quadrilaterals we've done: parallelogram, which is a pushed rectangle itself, rhombus, as well as square. All of these shapes, they both pair of opposite sides are parallel to each other, right? Here for trapezium, we find something interesting. Only one pair of opposite side is parallel to the other, right? As you can see here, we have 1 2 2, we have 1 2, we have 1 2. So only one pair is going to be parallel, right? So as soon as you see a quadrilateral with only one pair of opposite sides being parallel, you know what I'm saying? Yeah, so and I think this, it shows it much more perfectly, in a sense that you could have a pair of angles being equal, you could have no angles being equal, you could have a 90-degree angle. So it doesn't really matter about the angle, so long as you see a quadrilateral that have only one pair that is parallel to each other, trapezium. Right. Let me see, we talk about this one. So this one itself, it is a kite, né? So a kite, we see so the two adjacent sides are equal, and the two adjacent sides are equal, right? And then the diagonals, of course, they bisect each other. Only the diagonal BD can be split into two equal sides, right? So this is the center, meaning from B to here, let me say K, from B to K, BK and DK the same in length, right? Also the angles here are equal, the angles here are equal. So basically that is what a kite is, né? Yeah, I am done going through the quadrilaterals that you guys should know for grade 10. There is one thing I will say, ne? Pause the video, write these properties down, memorize them, know them by heart. From then, once you know them by heart, I'm telling you, mathematics or Euclidean geometry is gonna be one of the easiest, you know. Now I want us to take everything we have learned, right, and let us try to apply what we have learned on this example we're going to do next. Beautiful. They say prove that the diagonals of a parallelogram bisect each other at P. Right? Yeah, so they say prove that the diagonals, right? What are the diagonals of this? We have SN, we and SNNMR, right? These are the two diagonals that we have, and we are told that this is a parallelogram, and even we can see it. It is a parallelogram. Why am I saying that? A pair of opposite are parallel, a pair of opposite are parallel. And on top of that, it's a what? It's a quadrilateral. So yeah, then it becomes a parallelogram. Yeah? So I want us to take a moment. Let us just look at the quadrilateral itself, think about the properties of a parallelogram, and think of how can we actually prove that these diagonals bisect each other at P. Yeah? Yeah. So let me give you guys a little bit of a hint. Yeah, so we learned about congruency, we learned about similarity or similar triangles, and we went further to learn about different properties of quadrilaterals. So now the question is, what do you think, how do you think we're gonna attempt this? All right, so without wasting any time, let's get into it. We're gonna use congruency, right? And we're gonna compare this triangle and this triangle. We're gonna compare this triangle and this triangle. Let's get started. Right, so you would say in triangle M and P and triangle, yeah, this is okay. I haven't done it, but this is how you properly prove congruence in a like proper methodology. Yeah, these are like proper steps, né? These are like proper steps. In the previous video, I just wanted to give you guys an idea. So now we're doing proper things, yeah? So yeah, this is triangle M and P and triangle S, wait, R P. Let me see. Wait, what's happening? Wait. Bad. So in triangle MPN and triangle RPS. Yes, this is what's happening. I'll remove this. Let's cook. We'll say angle MPN equals to angle SPR, right? These are vertically opposite angles, right? And of course we're talking about angle here. Let's go again. So this angle right here alternate with this angle right here because of these parallel lines. So you will say angle MNP equals to angle PSR, right? Alternating angles, right? And this is angle. So now let's look. What do you think will happen here? They told us that this is a parallelogram, so we already know that MN and SR are equal. So MN equals to SR, right? So you would say reason opposite angle, opposite sides of a parallelogram. Yeah, parallelogram. That was long. So this is a side, right? So you see AAS, that means therefore triangle MPN is congruent to triangle RPS, right? And the reason is angle, side, angle, right? And then now what are we getting from here? We are getting that the focus is MP. I will highlight it here. So MP and RP are therefore equal. MP and RP, they are equal, right? So you will then say therefore MP and RP are equal, or you can just say MP equals to MP, right? And also because now they are equal, it says P is a midpoint of MR, right? MR, it's a, because now these two, they are equal, therefore P is a midpoint of MR. Let's now focus on these two triangles. Oh, running out of space. Let's see what we can do. Resize. I'll just put it here at the corner. Alright, so we focus on these other two triangles. It will basically be, you see, the exact same thing we've just done. We're gonna do exactly that, right? So now you have, let's see, in triangle blah, 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 blah. So it's this one and this one. So triangle SPM and triangle NP, yes, and PR, right? This is what you find. You find that angle MPS equals to angle NPR. Reason? Vertically opposite angles. Right here, let me remove these. You then find out that this angle, right, it alternates with this angle, right? So we go again to say angle MSP equals to angle P and R, right? These are alternating angles. You can also mention that after alternating angles, you can mention that they are alternating because MN is parallel to SR, right? That's very important. And then you're going to have MS being equals to NR, and these are opposite sides of, I'm just going to write the PAM for parallelogram, right? And therefore the two triangles, therefore triangle SPM is congruent to triangle NPR, and the reason of course is angle side angle. And from here what you will get is that, oh okay, SP must be equals to NP. That's what we are getting. I want to say so we know now that SP equals to NP, right? And therefore P is midpoint of SN, right? So from the first proof we showed that P is a midpoint of MR, and then now we have just shown that P is a midpoint of SN, right? From these two proofs we can then conclude to say therefore the diagonals bisect each other, right? Bam, bam. That's it. Let's look at this one. So on this one they say this shape, it is a quadrilateral, of course. Diagonal AC and BD bisect each other. Now they say that AC equals to BD, right? And I'm already seeing proof that there's a rectangle. The first one we are proving that it is a what? It is a parallelogram, right? So on proving that it is a rectangle, I will then say one of the things, I'm just being too forward here, one of the things for number B is that AC equals to BD, right? AC and BD, the only, okay, the same is true also with a square, but this is not a square. For rectangles the diagonals are the same, or the diagonals have the same length, right? So for here you would say that the diagonals, they have the same length, right? And that it shows that that you only find that in a rectangle. Right? So you would be done, I think, showing that this is a rectangle, right? And as for showing that this thing right here that we have is what is a parallelogram, right? Let's AT equals to TC DT, I'll just say this TB, right? But of course we know that all these are equal, right? It was given right? The reason why I'm saying all these are equal is because AC and BD are equal, right? And T is a midpoint of AC, therefore it's a midpoint of BD. Do you know what I mean? Yeah, so let's properly prove that, okay, this thing that we have right here is a parallelogram. You already know that AT, right, equals to AC. Ooh, equals to TC, right? And that was given to us. And then, of course, now let me pause. So we also see that BD, right, it bisects AC at where? At T, right? So BD bisect AC at T, right? I want you to keep on thinking. What do you think the next point is going to be about, right? Remember properties of a parallelogram, right? Let's forget, not don't forget. Let's go to BT, right? So you see also that BT equals to DT, and this was also given to us. This was also given, right? And also here you realize that wait. You realize that AC, it bisect what? T. Let's see. It bisect BT, BD, bad DB, BD. So this, it bisect AC, it bisect BD at T. Yeah, right. Look at the diagram. So 18 equals to TC, it was given to us, and then BD, this BD, it bisect AC here at T, right? And then now BT equals to TD, right? And BD, AC bisect BD at T, and therefore we're going to say that is going to be a parallelogram, right? Because the diagonals of a parallelogram, they do what? They bisect each other. Yeah, they bisect each other. So I have a nice one here. It's a kite, right? It's a kite. Let me bring it down. Unlock, then lock, right? So they say use the sketch to prove that the diagonals to prove that the diagonals of a kite are perpendicular to each other. Well, this one is quite interesting. This one is quite interesting. So we have a kite here, and we are trying to show or prove that the diagonals, they what? We are trying to show that the diagonals bisect each other or are perpendicular to each other. Yes, they are perpendicular to each other. Therefore, there's a 90 degrees angle here. Yeah. So let's think. How do you think, or what approach do you think we should go for this one? Cool. Let's get started. So in our diagram, we see that, so in our diagram, right? So, wait. My word. Oh, let me just say triangle ADB is an I might get the spelling wrong. What's happening? Let's look for the right spelling. Isosceles, because like what's getting isosceles. Isosceles. Yeah, so here's the right spelling. So it's the isosceles. Right, yeah. Bet you know. So triangle ABD is an isosceles triangle. ABD or ADB, doesn't matter. It is an isosceles triangle. The reason why the reason why we are saying this is an isosceles triangle is very simple. The two sides are equal, and if the two sides are equal, these angles must be equal as well, right? So you would then say like, yeah, since AD equals to AB, right? Angle ADO must be equals to angle ABO. Right. We get this information. We get it from where the triangle being an isosceles triangle, right? And of course, like I said, we concluded that the triangle is an isosceles triangle because of what? Because of the sides they are given to us, that the two sides of a triangle are equal, therefore making the two angles to be, and the two angles to be what? To be equal, right? So now I want us to do this. Say for example, angle angle DAB equals to angle DA. This should be O, because I want to focus DAO. I want to focus on the dot angle BAO, right? And that is given to us, right? And now say you're gonna say this. Let's say DAO equals to BAO equals to X, ne? And then we go again and say angle ADO equals to angle ABO equals to Y. Right, so now we look at our triangle again, and we're like, let us add all the angles that we have. Ne? If we add all the angles that we have, 1 2 3 4, they have to give us 180 degrees angles of a triangle, right? So yeah, and like I just said, this is Y, this is Y, this is X, this is X. Yeah, so in that triangle, in triangle ADB, right, angle DAB plus angle ADO plus angle ABO equals to 180 degrees. You would say angles of a triangle, ne? And then 180 degrees substitution. This angle is made by two angles, meaning X plus X, and then here you have your Y, so 180 degrees. Here you have 2X plus 2Y equals to 180. You divide by 2, you get X plus Y equals to 90 degrees, ne? So X plus Y equals to 90 degrees, ne? And now remember, we are saying X plus Y equals to 90 degrees. If these two angles are equals to 90 degrees, it must mean this angle is 90 degrees. And also the same that side. If X and Y are equals to 90 degrees, therefore this one must be 90 degrees, right? Then you will just make a conclusion that therefore angle AOD must be 90 degrees, ne? Yeah, and then from there you can then say therefore BD is perpendicular to AC, right? Yeah, yeah, yes. There's another longer method though, like, but this one, it's you're gonna use congruency to get to this conclusion, right? That angle ADO equals to angle ABO. You're gonna use congruency, and then from there on, you come here, right, and then you go here, and so forth and so forth. But it's very long, so if you could see that that's an isosceles triangle, it saves you a lot of time, right? Yeah, here's another cool one. I think this will be the last one. Okay, I may need to bring it down. So they say find the area of, I bet, so we are finding the area of this parallelogram, and we are told that AB is 8, BF 17, FE equals to EC, BE equals to ED, right? And angle A is 90, and then angle CED is 90 degrees. Right. Yeah, so quite interesting. So now we have to find the area of this parallelogram. No, let me not say it's not a parallelogram. If you can see properly, it's a I believe this one is a trapezium, right? Because it looks like they didn't say it, right? But it looks like AC is parallel to FD. Yeah, so let's pause right now. Let's pause and let's think about these, right? Cool stuff, né? Let's get started. So one of the reasons I did say that you need to know by heart the properties of parallelograms, rectangles, kite, rhombus, square, all of them. All of these quadrilaterals that we did, you need to know their properties now. Because now you look at, let's look at B, C, D, F. Okay? What do you see? The diagonals, this equals to this equals to that being the midpoint, and there being a 90-degree angle. Therefore, this is a what? It's a rhombus, right? This is a rhombus. Rhombus. Right, you look at the angle, not the angle, you look at the properties that are here, the sides, the diagonals, then you conclude to say, no man, this is actually it's actually what we call a rhombus. And from this being rhombus, you remember that all sides are equal. From all sides being equal, you then conclude you have 17, and 17. Right, cool stuff. So hey, so one of the most important things now is you need to make sure that when you have a problem and you don't understand this problem, right, I want to, okay, how do I put this? When you have a problem and it seems very challenging, I will tell you, work with what you know, right? Don't try to think of things you haven't done before, whatsoever. Work with what you know. They ask us to find the area of this whole thing, right? So, but what if, here, listen, what if we construct, right? um we construct this is not straight enough. Cool. So we construct that, ne? We have A, B, C, D, E, F. So we have G, ne? So number one, you construct C, G, right? Yeah, C, G, such that AC equals to FG. Ne? This is your construction. You construct CG such that AC equals to FG, right? And then from construction, we will then say, therefore, AB must be equals to DG. You see it, ne? Bad. So what we can actually do now, we have a rectangle, right? So A, C, G, F, it is what? It is a rectangle, which we know the area of a rectangle is what? Length times breadth, right? We say length, which is the two combined, 17 plus 18, that will be 25. 25 multiplied by whatever AF is. In fact, let's calculate it. We're going to use Pythagoras in triangle AFB. ABF, right? In triangle ABF, right? This is happening, right? 17 squared is equals to 8 squared plus AF squared, ne? Then this is 17 squared minus 8 squared, AF squared. AF squared will be 17 squared plus minus 8 squared, and we get into 225 squared. We then make square root both sides. AF is gonna be what? 225, 15, right? So we have just calculated this side is what? That side is 15. So we working from what you know, ne? You can calculate what? You can calculate the you can calculate the area of this rectangle and then subtract the area of this this gentleman here, of this triangle, because this triangle CDG is not part of the area that we are calculating, ne? So that's the idea. That's what we are going to do, right? That's what we are going to do. So let me go to the point we made initially. So upon construction, we constructed this such that AC and FG are equal, and then from them being equal, it also meant that AB would be equals to DG, right? So AB and DG are equal, right? So now the thing is, we don't know this side what it is, right? We have a right angle there, right? We don't know what length this side is, right? And just like we did here, we'll use theorem of Pythagoras. We have 8 here, you have 8 here, you have 17 here, you do your calculation just like we did, you're gonna get that here you have 15, right, by just using purely Pythagoras theorem, right? And then after doing all of that, let me erase this for space, delete. After doing all that, we can then say area of ACGF is gonna be length times breadth, right, which is gonna be 8 plus 17 multiplied by 15, right? So let's go 8 plus 17 multiplied by 15, we are getting 375. Then you find area of triangle CDG, which is half base times perpendicular height. So that's going to be 1/2 multiplied by 8 multiplied by 15. So that is going to be probably 60. 0.5 times 8 times 15. Damn. 60. And therefore area of ACDF is equals to 375 minus 60, which is 315. Yes. Yeah. So that right there, friends, is the area. So yeah. Yes, so that is the end of this video. The next video will be talking, you just saw, we're gonna talk about midpoint theorem.